Welcome to week 3 of the Soils course, PS 101, Basic Soil Science. As you can see, I have a video. I have several things to look at, and I hope I can manage them without losing them. First of all, I have, the week 3 module up. Contains the week 3 overview. I don't think I have an intro module for this, so let's look at that overview since I have it. Maybe I can do it without losing it. There it is. Really, it's quite simple. This module will cover specific soil behaviors such as shrink, swell, and compaction, and these behaviors and how they impact a project cost. So at the end of the module, you'll be able to explain why soil swells when it's excavated, calculate the swell factors of different soils. That will be depending on their weight per cubic yard, and explain the trade terms listed in Section 2 of the NCCER module. You might recall that this Section 2 I snagged out of an entire NISA module 22308, which is all about soils. I organized the pages using Acrobat DC and put them into sections so it won't take so long to download them. So this will be where the video is going, right here, this video. Now, having said that, I need to go back to the modules. And I want to go down this real quick. We saw the overview and what the objections are, shrink and swell, how to calculate them. But the big deal about this is the assignment. There is a scenario, and that scenario is located on page 17, I believe it is, of the Section 2 portion of the NISA module. And so it'd be on page 17. And I actually have it hiding up here somewhere, right there. There's Section 2. It's also available under instructional resources. So the first thing you probably want to do is read that module, and make sure you're understanding it. And toward the end, I think, is that scenario. In the scenario, let's go back and see what the scenario asks us to do. I forgot that. Let me find it. I think it's right here. There it is. More of a kind of an overview. This is where I'm going to put the video. Here's where I typed it for you so you could reread it on page 17 of Section 2, which it's this whole document from the NCCER Soils module. There's a scenario, and it's subsection 2.3.1. The NCCER Section 2 link is located in this module, week 3, just below instructional resources, and that's the reading assignment I gave you just a minute ago. In the scenario, you need to excavate some damp sand from a borrow pit and take it to a building site. You'll be given 3 trucks, and the weight and volume capacities, I forgot to put that word in there, the weight and volume capacities of each truck. What your challenge is select the truck, the best truck that can efficiently move the material to the building site. The video I'm going to present will go through the scenario for the most part and provide all the calculations that you will need to carry out this mission. So with that, I am going to get this out of the way. I think. Let's see if I can sneak it out of the way like this. Yeah, here it is. And this is the week we're in. This is the assignment where the scenario is. And there is an assignment video that I made a year or so ago right here. And I put it up there to help you with this. But I think I'm going to take it out because I've got so much information in that video that I'm afraid this will do more harm than good. I actually took what was in the book and I didn't really reword it, but I changed some things around to simplify it. So I think it's going to be best that you don't have this, but this will be self-explanatory. In other words, it'll tell you what you need to do. And it, for the most part, tells you how to do it. When it comes to the end, though, you're going to have to figure out, with all these calculations you've done and all the results of those calculations, what's given the three different trucks that have three different weight capacities and three different volume capacities. Now, it gives you a heaped weight and volume, which would be much greater than what's called a struck weight capacity and volume capacity. I want you to go by the struck weight. If you don't know what that is, that's just like if you pile dirt in the bed of a dump truck, it heaps up to a mound. A struck weight is if it was level at the top, and that can be found, I'll show you where in just a moment, as soon as I get through with looking at our week 3, which I feel like I am through now. So let's see if we can bring up what's hiding behind the green door. This guy. I want these two up at the same time. Heaven knows where the modules went. But this is section 2. And the first thing that you will need to know is terms. These performance tasks, maybe we'll get to do those if we can find somebody to come out during our in-person training toward the end of the term with a nuclear density meter, and we'll do some actual soil testing. That is my hope. I worked on it. So banked is any soil mass that is to be excavated. In other words, it hasn't been dug up. It's in its natural state. Consolidation is a little bit like compaction, but it's not. So it's the definition here is to become firm by compacting the particles so they will be closer together. Now, that's okay. We'll let that go right now, but I want to separate this. Settlement is to become firm by compacting the particles so to be closer together. They're different though. Both of these, consolidation and settlement, are not done on purpose. In other words, over time, rain, the weight of the building structure will cause some unintentional compaction, let's say. So we want to deliberately compact all of our material before we put a slab on it, before we put a building on it. So we know it's compacted to the point that we want it to be. Now we're going to talk about a swell factor, but swell is the increase in volume when soil is excavated. If you ever dug a hole and then needed to fill it up and couldn't get all your soil back in it, that's because when you bring it out of the hole, air mixes in with the particles and the weight doesn't change, but it gets bigger, the volume. So it's an increase in volume when it's disturbed or excavated. The swell factor is a ratio of banked weight, which is its natural state. In other words, I'll use the word naturally compacted over maybe 100 years. but it's the ratio of the bank weight of a soil to the loose weight of a soil. Now, somewhere is a chart, table number 6, and here it is. This is to give you an idea. Now, before we get started, it's about this is loose weight. That would be after it's been disturbed. This is bank weight. That's before it's been disturbed. So it's available to you in kilograms per cubic meters or pounds per cubic yard. We will stick with pounds per cubic yards. Bank weight, the same. So when I started out, I talked about damp sand. And there it is for you. You go over here, and we don't want kilograms. We want pounds per cubic yard. That is the loose weight per cubic yard, 2,850 pounds. This is the bank weight in the same yard, the same volume. It's heavier, see? It's 3,200 in bank weight. In other words, bank weight is tighter. So a cubic yard of loose weight that contains air voids is going to be lighter than a cubic yard of bank weight, which essentially doesn't have any air voids in there. So compaction is to get rid of air and any moisture that's not needed in the soil. I'm not going to do much reading out of here because I've taken a lot of this and I've put it over here, and it's pretty much copy and paste, but I've changed a few things and added where I put different words in there. But let's sneak down here just a little bit. If to make a, I don't want to talk about this in this way. That's why I did this. So if I want to find the swell factor, now the swell factor is what we're really after, and you use the loose weight in relation to the bank weight to get it. It's actually found by taking the bank weight and dividing it by the loose weight. Here's an example, 3,500. Let me get my little calculator out. 3,500 divided by 2,800. So that's 1.25. So if you want to know how much your soil with a swell factor is, how much bigger it's going to get volume-wise, you would multiply the hole you're going to get it out of time that volume of that soon-to-be hole. When that dirt's brought out of there, it's going to weigh 1.2. It's going to be 25% heavier. 1.25. So you take 1.25, multiply it, let's say times 100 cubic yard hole in the ground, and you're going to have 125 cubic yards of fill laying on top of the ground. And this one, that's just an example. Now we were looking at damp sand, right? So look at that. That's 3,200. We're going to have to calculate this eventually because we're going to need to know the swell factor of the soil that we're excavated. So 3,200 divided by, where's my damp sand? 2,850 right here. 3,200 divided by 2,850 equals 1.12. So we're going to be dealing with a soil that has a swell factor of 1.12. It's 12% more once you dig it out of the hole. The next factor that we talked about, so the again, here's the little calculation. It's calculated by dividing the bank weight by the loose weight, bank by the loose weight. So the next thing we got to figure out is, let's see what I've got over here, trade terms. When the soil was used to fill and pushing air in the pockets out and gives the appearance of shrinking volume. Actually, it does occupy less volume because of compaction. If you have an open excavation equal to 100 cubic yards, depending on the type of soil, it will take more than 100 cubic yards to fill and compact the open excavation. And then I say just how much more depends on the type of soil that it takes us, and that takes us to the swell factor. And that's where we are right up here. So let's read mine a little bit and see how that does. Let's see what I talked about first. Pretty much the same thing. It's easier to read over here. As soil is excavated from its natural position, it is mixed with air and gives the appearance of swelling in volume. It does create or occupy more volume. When the soil is used as fill, it is compacted, pushing air pockets out, and gives the appearance of shrinking in volume. It does occupy less volume because of compaction. If you have an open excavation equal to 100 cubic yards, depending on the type of soil, it will take more than 100 cubic yards to fill and compact the open excavation. Just how much more depends on the type of soil, and that takes us to the swell factor. And that's on 2.1.0, page 14. Let's see if I talk about it a little bit. Undisturbed soil is called banked, while excavated soil is called loose. Loose weight of the soil is always less than the bank weight for the same volume, like we deal in cubic yards. 1 cubic yard of banked soil is going to weigh more than 1 cubic yard of that same soil in a loose state. So, this is because air, which weighs almost nothing, is mixed with the soil when it's excavated, increasing the volume and decreasing the weight per cubic yard. This increase in volume is called swell. On table 6, which we just visited, there it is again, and look at table 6. The swell factor of the soil is found by dividing its bank weight by its loose weight. According to table 6, wet clay, for instance, right here, wet clay is 2,800 loose pounds per cubic yard, and it's 3,500 pounds per cubic yard when it's in its bank weight. Increasing the volume, table 6, the swell factor. According to table 6, wet clay has a bank weight of 3,500 and a loose weight of 2,500 pounds per cubic yard. So we would take 3,500 divided by, and the swell factor for wet clay is 1.25. So if you're digging out wet clay, when they lay it on the ground, it's going to increase by 1.25, which is 125%, if there is such a thing. But you just take the cubic yards and multiply that it's going to be, that's in the hole that you haven't dug out yet, how many cubic yards you're going to dig out of bank, multiply it by 1.25, and you'll get your volume once it's out on the ground. So when excavated, the images on figures 16, I don't know where the M came from, but 16, 17, 18 are confusing to me. So let's see if we can't find those images right quick. This right here is illustrating shrink and swell. I promise you that when I try to figure this stuff out by going by these cubes and these, like this is a quarter of the a quarter, like 700 pounds is a quarter of, is 25% of the where's the total up here? This would be 1, 2, 3, 4. This would be 2,800 pounds. And 0.25 times 2,800 is a quarter. And that's 700 pounds. Anyway, you can use these for your own if you want. I mean, I just don't like them. I stick to the math, and that's what I got over here mostly is the math we're going to use. So let's review. Swell factor is simple. It is the bank weight. The bank weight divided by the loose weight in pounds per cubic yard. Simple. And that is a factor. A factor is something you multiply by something else to get its true value, weight, whatever, length. That's a factor. Remember, if you had hydraulics with me, we had a force factor, depending on when we were using force multiplication. So factors are something you multiply to get the real result that you need. So that's that. Now, I don't want, if I want to see this stuff right here, they go ahead and tell you this, and then they say it doesn't matter. So I'm staying away from this, and feel certainly your first time through here, read this, see what you can figure out. This over here is not a summary, but it's just the same thing in kind of a redistributed form that I like. So we've gone through here. Now we're going to go to the shrink factor. We've gone through a swell factor right here, and we came up with 125. 1 cubic yard of bank wet clay equals 1.25 cubic yards. See there? When it's excavated. The images on figure 16, 17, 18 are the ones that I don't like. So I'm not going to talk about them, but feel free to go back and see if they can help you. What I did was put down calculations you will need to complete the assignment that is this scenario right here. All this. This is the information you're going to be given, and it goes back to this. But this tells you what the problem is, and then it tells you step by step. Now, it may not follow down this way. So there's the second step, and I think the third one is up here. And no. But anyway, when you get the whole thing out there, you'll be fine. First, second, and third step, and then it goes to the trucks. Kind of want to find it though first. Where did I find the second? I know this is driving you crazy. Nope. I may have to forget that for now. I cover it over here in my readings, which is a little bit easy to read, but I just kind of wanted to find it so you would know what page it was on. First step, determine that, and then a second step is calculate the swell factor. Here you go. Third, we already know that we need 125 cubic yards, and that was determined way back early as we was going over when we first started, we took 100 and I think divided it by the shrink factor. But we'll get to that. I put this up so I wouldn't confuse you, but I feel like it's just hard to present this without confusion in it. So let's just take a look at this week 3 video outline I made. This is the things that we've read about. We've read about the trade terms. We've talked about the banked and the loose yards, and we've looked at table 6 that shows you loose weight and bank weight of the different soil. Now we're going to look at the shrink factor. The swell factor, these are just calculations. The swell factor is the bank weight divided by the loose weight. I gave you the example of the sand that you're going to be delivering right there. It's going to have a swell factor of 1.12 because it's 3,200 bank and 2,850 loose, and that's going to give you that swell factor. Now the shrink factor, this is a different animal. To find the shrink factor, I have to take the compacted volume and divide it by the loose volume. So if I have a hole that needs to be filled and it's 80 cubic yards when it's filled up and compacted, I would divide that by the loose volume. So the shrink factor is 0.8. And if you take 0.8 and multiply your shrink factor times your loose volume, you will go back to 80 cubic yards. That will give you that. Using the shrink factor to determine how much fill is needed. So compacted volume divided by shrink factor. The compacted volume is 100 cubic yards in this case, divided by the shrink factor, and you will get 125 cubic yards. That's how much soil you will need if you want to fill that hole up to, we determined the soil has a shrink factor of 0.8, and if you want to know how much loose soil you're going to need to fill that 100 cubic yards, you're going to divide it by the shrink factor, and this tells you that you're going to need 125 cubic yards of loose yards to fill the 100 cubic yard hole and compact it. Now, here's the scenario. And these are the factors, these are the calculations that we're going to use. You need to excavate some damp sand from a borrow pit and take it to a building site. The sand has a swell factor of 1.12, which we did way over here. And we did it again up here because the damp sand was 3,200 bank, 2,850, and that has a swell factor of 1.12. So that's the material that we're going to be using. This right here, this 125 cubic yards of soil that we're going to have has a swell factor. So let's go back to the scenario. You need to excavate some damp sand from a borrow pit and take it to a building site. The sand that we're going to excavate, as we found out, has a swell factor of 1.12. And we did that by doing this division of banked divided by loose. You need to fill an area with the volume of 100 cubic yards. It's a hole in the ground, empty, but it's a 100 cubic yard hole. This material has a shrink factor, the material that you're going to put in there, of 0.8 when it's thoroughly compacted. This is what's going on here. So first, determine how much fill is needed. I think we did when we did this right here. We took the compacted volume and divided it by 0.8. And when you take and that if you divide 100 cubic yards by the shrink factor, 0.8, you will get 125 cubic yards. So that's what it's going to take. This material that we're talking about has a shrink factor of 0.8 when it's thoroughly compacted. So first determine how much fill is needed since the compacted volume is 100 cubic yards and the shrink factor is 0.8. Right there, again, 125 cubic yards of material. 100 divided by the shrink factor equals 125 cubic yards. The next thing you do is calculate the swell factor. We've already done that. It's 1.12, and we did it right here. 3,200 divided by 2850. So that we calculate the swell factor of the excavated material. We did that, 1.12. You already know you need 125 cubic yards of fill or loose. That was calculated in the first step. How much banked material? Now we're wanting to know how much undisturbed or banked material must be calculated to get that 125 cubic yards of fill. So the way we do that is to divide the desired amount of fill, which is 125, by the swell factor, which is 1.12, and that will give you 111.6 cubic yards of banked material that we need to dig out of the hole, so we'll have 125 cubic yards because it's going to swell from here to here because of what we did. Amount of fill, 125 divided by the swell factor, and that's how much soil we gotta dig out to get 125 cubic yards of banked compacted material. So because it's going to swell to 125 cubic yards of loose material. And to prove that, just take that 111.6 and multiply it times that swell factor of 1.12. You'll get 125. So we need 125 cubic yards of loose, damp sand delivered to the site. The material weight is 2,850 pounds per cubic yard. That's loose. That's what we're going to use right now because it's loose. It's 100 multiply that times 125. 1 cubic yard weighs 2,850, but we need 125. So that means the total weight or yards of soil we need is 356,250 pounds. That's how much we got to deliver. So I'm going to let you do it, but I did it a quick way in my mind. I took these truck capacities. Let's go find the truck capacities. There they are. Truck A, 18.8 cubic yards in volume heat. You can put that volume capacity at 18.8. Truck B will hold 22.1 heat cubic yards. In other words, we filled it up. Truck C will hold 30 cubic yards. Now, here are the weight capacities, the rated payload. So if we have 22.8 cubic yards and we multiply that times 30, what is that going to give us? That's going to give us, I'm sorry, that's not what I want to do. If we have 22.8 yards and we multiply it times what? 2,850 per yard. What does that give us? Right here's where I did truck C. Right here is dam load material weight, 2850 pounds per cubic yards. We need 125. There's the total weight. So truck C has 22.8 cubic yards struck right here. So multiply that times, so we get 64,980 pounds. We can do that because we're under the rated capacity. So it can haul one trip of 64,980. That's one trip. So if you take 64,980 pounds, take 356,250 pounds and divide it by 64,980 pounds per trip, you'll get 5.5 trips. So I picked truck C. I did it just purely by weight. I think there would be other considerations, and it might talk about those when you're over here, like it's doing the same thing, and you got to make sure it's within the weight capacity. So you got to see, they go through all the trucks for you, but divide the total quantity, 125 yards, by the struck volume capacity. That's the way they did it. And I can't see, but they stuck with the volume. I kind of stuck with the weight. This is going to just give you a chance to go through the different calculations for shrink and swell. And I felt like I would either really doubly confuse you. Shrink and swell can get confusing. But let's stop there, and I want to encourage you to call me if you have a question, or text me, or whatever your preference of communication is, and let me know. But I'm going to stick this video in week 3, and hopefully it'll help us out a little bit. There is an assignment now that's going to ask you. I think the assignment is asking you to do the scenario. So go through it, practice it. You don't have to be perfect. If I see you're on the right track, I'm going to be happy. But I'm going to stop right there and then go back, and you can go back through here, pick out some things, and go back to the module or week 3. Look at that, make sure everything's. There's also tailgate in there. And I want you to do that too. So you'll have a quiz in there, you'll have a tailgate, and you'll have this assignment. So you have 3 opportunities to build up your score. So I'm going to exit here. And this is not yet, you haven't started yet, but by the time I get this up, you will start on the 7th.